Photosynthesis is the process by which green plants and certain other autotrophic organisms manufacture their own food material in the form of carbohydrates from carbon dioxide and water in the presence of chlorophyll and sunlight through a complex series of reactions within the organism. In other words, it is a process of converting light energy to chemical energy. Photosynthesis takes place inside cellular organelles called chloroplasts, which contain abundant photosynthetic pigments called chlorophyll. Chloroplasts are found in abundance in green leaves and are therefore the major site of photosynthesis in plants. Gaseous oxygen is a major byproduct of the process of photosynthesis. The chemical reactions that take place in this process may be summarized as follows. Photosynthesis occurs in two major steps, both of which take place within the chloroplasts: a light reaction and a dark reaction. Starch is eventually formed as a reserve food by plants at the end of a photosynthetic process. If a plant is stripped of any one or all of the vital factors necessary for it to carry on photosynthesis, then photosynthesis immediately ceases to occur in that plant. As a result, the plant starts utilizing its existing reserve food that has been stored in the form of starch. Eventually, the plant would have used up all its remaining stored starch and become what is known as a destarched plant. A destarched plant cannot remain alive for long, unless it is resupplied with the vital factors necessary for photosynthesis to occur. The absence or presence of starch and thereby photosynthesis is determined using iodine solution, which turns blue-black in color in the presence of starch but retains its original brown color in the absence of starch. In this experiment, we're going to investigate the role of light in the process of photosynthesis and find out if light is indeed necessary for photosynthesis to occur in a plant. For this experiment, we'll need the following: a potted plant preferably with wide leaves, water bath, a large test tube, ethanol or isopropanol or methylated spirit, aqueous iodine solution, petri dish, forceps, a piece of black paper, a pair of scissors and sticky tape, paper clips. Begin the experiment by placing the potted plant in the dark for about 2 to 3 days. This step is essential in order to rid the plant of any starch that was formed in the leaves prior to the start of the experiment. At the end of this time period, remove the potted plant from the dark. Cut a piece of black paper, like so, and secure the cut end of the paper using a sticky tape. To make this experiment a bit more interesting and fun, I have carved out my initial, which is the letter T, as well, on the black paper covering the leaf. Cover both surfaces of one of the leaves using this piece of black paper, like so, and secure the paper on the leaf using some paper clips. Now what we can see here is that these parts are exposed to light, while the parts of the leaf covered by the black paper will continue to remain in the dark. Leave the potted plant in sunlight for several hours. Then, detach the leaf from the plant and remove the black paper from the leaf. Now, introduce the leaf into the test tube containing the alcohol solution. Place the tube in the boiling water bath. If you're using an open flame such as spirit lamp or Bunsen burner for your water bath, then make sure to turn off the burner flame once the tube has been placed in the bath. This is to make sure that the alcohol fumes do not catch fire during the boiling process, which is a huge possibility considering the highly flammable nature of alcohols. Alternatively, you may use a hot plate for boiling like the one I'm using here instead of an open flame. During this boiling step, chlorophyll pigments in the leaf are decolorized by the hot alcohol solution, resulting in a bleached leaf with pale white color. This step is necessary for a better visualization of the iodine-starch reaction on the leaf surface in the later part of this experiment. Once bleaching of the leaf has been accomplished, remove the leaf from the alcohol using a forceps. Briefly place the leaf for a few seconds in the hot water bath in order to soften the leaf. Transfer the leaf in a petri dish containing iodine solution. After a couple of minutes, you will see that the exposed parts of the leaf not covered by the black paper turn blue-black in color in the iodine solution. The part which was covered by the black paper, however, do not show any significant change in color except for a faint brown iodine color. This is a negative test for starch and thereby photosynthesis. This simple experiment clearly demonstrates that light is an essential external component for photosynthesis to take place in a plant.